The Saturn in your textbook is gone. Not metaphorically, physically. The planet that Cassini orbited for 13 years, photographed from every angle, mapped down to its hexagonal storm and its bleeding rings, has shifted into a configuration no human instrument has ever recorded before. James Webb caught it first. Hubble confirmed it. Ground-based observatories from Hawaii to Chile are now publishing data that contradicts the reference frame an entire generation of planetary scientists trained on. Saturn did something between 2017 and 2026. That, according to the geological record, it has not done in 4.5 billion years. And almost no one is talking about it. Wherever you are watching from tonight, take a second and ask yourself when you last saw a Saturn headline that was not just recycling Cassini footage from a decade ago. There is a reason for that silence. The footage is beautiful. The footage is famous. The footage is also increasingly a portrait of a planet that no longer matches the one in the sky. Cassini was sold to the public as the definitive Saturn mission. Definitive. That word implies a finished study of a stable object. But a definitive snapshot of a moving subject is not a portrait. It is a freeze frame. And the subject did not hold still. Here is the part that should bother you. Every textbook printed after 2017 is teaching the Cassini-era Saturn. Every documentary streaming on every platform is showing you a planet that telescopes are no longer seeing. Every classroom lesson about ring composition, atmospheric chemistry, magnetic field structure, and seasonal storm behavior is calibrated to a 13-year dataset. That, in the strictest scientific sense, has begun to expire. The data is not wrong. The data is dated. And the gap between what we taught and what is actually happening up there is widening every month JWST points its mirrors in Saturn's direction. The mission was not a failure. The mission was extraordinary. The error was ours. We assumed 13 years was long enough to know a 4.5 billion-year-old object. We assumed the planet would wait for our follow-up mission. It did not. And what changed is not subtle. It is not a slight variation in cloud bands or a marginal shift in stratospheric temperature. It is something Saturn has never been observed doing in human history, and the geological evidence suggests it has not done it in the entire lifespan of the solar system. The official story, the one NASA told you while Cassini was alive, and the one it has kept telling since the spacecraft burned up in Saturn's atmosphere in September 2017, goes like this. We sent a probe. The probe worked. The probe found wonders. Hexagonal storm at the North Pole, mapped in detail. Enceladus venting water plumes through cracks in its ice shell. Plumes that hinted at a subsurface ocean and possibly the chemistry of life. Titan's hydrocarbon lakes, the only stable surface liquids known beyond Earth. Ring composition characterized particle by particle. The grand finale, 22 daring orbits between the rings and the cloud tops. Gathering data nothing else ever will. Mission complete. Headlines triumphant. Funding justified. It is a good story. It is also, in the way these stories always are, a softened version of the actual scientific situation. Read the press releases carefully. The language is celebratory but careful. Cassini revealed. Cassini transformed our understanding. Cassini opened new questions. Notice what is not said. Cassini did not finish anything. Cassini did not give us a stable model of Saturn that would hold for the next century. Cassini gave us a 13-year window into a system we had previously seen only in flybys. And the agency framed that window as completion, because completion is what flagships are sold on. This is not a conspiracy. This is how science communication works. You cannot tell taxpayers and Congress that a $3 billion mission was a partial measurement of a moving target. You tell them it was a triumph, and in the moment, in 2017, it was. But triumph is a description of the mission, not a description of the planet. Here is where the framing starts to break. Mission success was measured in data volume. Terabytes returned, papers published, press conferences held. None of those metrics asked whether the Saturn Cassini documented would still be the Saturn telescope saw 10 years later. The word baseline got used a lot. Baseline atmospheric chemistry, baseline ring composition, baseline magnetic field behavior. Baseline is a powerful word. It implies a stable reference against which future observations can be compared. But baseline only works if the underlying system is stable enough to have one. A generation of viewers now believes Saturn is solved, a closed file. The mission ended, the textbooks were updated, the documentaries got their footage, and the public attention moved on to Mars rovers and Europa Clipper. The cracks in that closed file did not appear in 2017 when Cassini burned up. They appeared the moment newer instruments looked at the same planet and saw something different. To understand what changed, you have to understand what Saturn actually is. Not the picture book version, not the Rings and Stripes cartoon, the real thing. Saturn is not a passive ball of gas with pretty decorations. Saturn is a thermodynamic engine. Every component of the system is coupled to every other component, and the coupling is active, ongoing, and measurable. The atmosphere drives the magnetosphere. The magnetosphere channels charged particles from the rings. The rings bleed material back into the atmosphere. The internal heat, which exceeds the heat Saturn receives from the Sun, drives circulation patterns that should not exist in a static body. None of this is stable in the way a mountain is stable. It is stable in the way a hurricane is stable, which is to say, not at all in the long term. Start with the rings. Cassini measured something during its grand finale that planetary scientists are still trying to fully process. The rings are raining into the planet. Water molecules, ice grains, and charged particles are falling out of the ring system and into Saturn's upper atmosphere at a rate of roughly 10,000 kilograms per second. Let that number sit for a second. 10,000 kilograms every second. That is the mass of a fully loaded delivery truck disappearing from the rings and entering the planet every second continuously for as long as we have measured it. Now, translate that into something a human can feel. The rings you see in every Saturn photograph, the rings that have defined the planet in the public imagination for 400 years since Galileo first squinted at them through a hand-built telescope, are not a permanent feature. They are a melting glacier. You can see them because they are disappearing. The visibility is the evidence of the loss. This is the part most people never hear. The rings are not jewelry, they are a slow-motion drain, and the drain is connected to everything else. The material falling into Saturn changes the chemistry of the upper atmosphere. The chemistry of the upper atmosphere changes the auroral activity. The auroral activity is tied to the magnetic field. The magnetic field interacts with the solar wind. And the solar wind varies, which means Saturn's entire system is in constant feedback with a sun whose output is also not constant. Cassini measured the bleeding. Cassini measured the heat. Cassini measured the magnetic structure. But Cassini measured all of it across 13 years and assumed the rates were close to constant. New data says the rates are not constant, and that single broken assumption invalidates the foundation a 13-year dataset was built on. Here is the fragile number. Cassini-era models of Saturn's atmospheric circulation assumed that the dominant variable controlling change was the seasonal cycle. Saturn takes 29.5 Earth years to orbit the Sun. That gives it long seasons, roughly 7 years each, and the assumption was that everything observable, the temperature gradients, the cloud band shifts, the auroral patterns, the chemistry of the stratosphere, would track that orbital rhythm. If you knew where Saturn was in its season, you could predict what it should look like. That was the model. That was the framework Cassini's 13 years were built around. 13 years is not even half a Saturnian year. The mission caught less than a single full season cycle, and from that fragment, an entire predictive structure was assembled. The structure held until JWST started looking. James Webb's mid-infrared spectroscopy, beginning in 2024 and continuing through 2026, detected atmospheric chemistry shifts that do not track the seasonal model. Hydrocarbons in the stratosphere are distributed differently than the Cassini-era predictions said they should be. Temperature gradients between equator and pole are not where they were supposed to be at this point in Saturn's orbital position. The equatorial jet, the high-altitude wind structure that wraps around Saturn's middle, is behaving in ways that the existing models cannot reproduce without rewriting their core assumptions. The auroras are another piece of this. Saturn's auroras, mapped extensively by Cassini and by Hubble's long-running OPAL observation program, are showing patterns that deviate from what the magnetic field model predicts. The ring spokes, those mysterious radial features that appear and disappear on the B-ring, are timing themselves on a rhythm that does not match the seasonal prediction either. Each of these is a small thing on its own. Together they tell a story. The story is that the seasonal model was incomplete. Something else is driving Saturn's variability, and that something else operates on a timescale humans have never measured. Because no one has ever watched Saturn long enough. Now think about what this means for the people whose job is studying Saturn. Every planetary scientist who built a career on Cassini-derived models is now publishing corrections. Some are publishing reinterpretations of data they themselves analysed a decade ago. Conference talks in 2025 and 2026 have started to carry a tone the field has not heard since the early Voyager era, a tone that admits quietly that the reference frame is breaking. And when the variation is not seasonal, the obvious next question is the one that should bother everyone in the room. What timescale is it on? Here is the answer that breaks the comfortable framing. The timescale is not seasonal. It is not annual. It may not even be measurable on human civilization timescales, because the thing Saturn is doing right now, the slow restructuring of its ring-atmosphere coupling, the active loss of the rings into the planet, the chemistry shifts that do not track any cycle we have a model for, is part of a transition phase that has no precedent in the 4.5 billion year history of the solar system. Not because the solar system has not seen ring loss before, but because Saturn's rings, as we know them, have not existed long enough to have a precedent. This is the number that should stop you. Cassini's final orbits, the grand finale data, allowed scientists to measure the mass of the ring system with a precision no flyby had ever achieved. The total mass came in lower than expected. Lower mass, combined with the measured rate of ring rain bleeding into the atmosphere, allowed planetary scientists to back-calculate the age of the rings. The answer, published in 2019 and refined since, is that Saturn's rings are between 100 and 400 million years old. Possibly younger, possibly much younger. The planet is 4.5 billion years old. The rings are, at most, a tenth of that age, possibly a 40th. Saturn spent most of its existence without the rings that define it in every photograph you have ever seen. Now scale that forward. At the current measured rate of mass loss, the rings will be gone in 100 to 300 million years. Gone. Not diminished, not faded. Gone. The defining feature of Saturn, the feature that distinguishes it in every solar system poster ever printed, is in the process of disappearing on a timescale that, while long compared to a human life, is geologically brief. This is the scale rupture. Saturn is not doing something unusual within its normal range of behaviour. Saturn is doing something it has measurably never done across its entire lifespan. Because the configuration that allows this behaviour, a young, massive ring system in active decay, has only existed for the last few hundred million years. The implication is harder than most documentaries are willing to state plainly. We are not observing Saturn. We're observing the brief window in which Saturn is recognisable. Before that window opened, there was no ringed planet. After it closes, there will not be one again. And we, alive right now, are watching that window in real time, with the only dedicated mission already finished and burned to atoms. Now think about who has to live with that gap, not the planet. Saturn is fine. Saturn does not care that its observers ran out of funding. The people who have to live with the gap are the scientists, the graduate students, the mission planners, the textbook writers, the teachers, and the next generation of researchers who will spend their careers working from a reference frame that is already known to be expiring. Imagine training as a doctor using a textbook that describes a patient at age 40. You memorize the patient's measurements. You learn the patient's normal ranges. You pass exams on the patient's expected behavior. Then you walk into the clinic and meet the patient, and the patient is 60. The same person, the same name. But every measurement you trained on is calibrated to a body that no longer exists. You can still treat the patient, you can still make good decisions. But you are working without a current baseline, and every diagnosis you make has to account for the gap between what the textbook said and what the patient is now. That is the situation every Saturn researcher is currently in. Cassini's data is the textbook. The textbook describes a planet at a specific moment in its evolution. The planet has moved on. The textbook has not been replaced. And there is no funded plan to replace it on any timescale that matters to the careers of the people doing the work. This is not a hypothetical. ESA and NASA Outer Planet mission planning documents still cite Cassini as the foundational dataset for any future Saturn science. Every paper proposing a Saturn return mission, every concept study for an orbiter or atmospheric probe, begins from the assumption that Cassini's measurements are the starting point. But Cassini's measurements are starting to function less as a baseline and more as a historical record. The difference matters. A baseline tells you what is normal now. A historical record tells you what was normal then. JWST is helping, partially. It has Saturn observation time. But JWST is contested infrastructure. Every hour pointed at Saturn is an hour not pointed at exoplanets, early universe targets, or the dozens of other priorities lined up behind it. JWST was not built to be a Saturn observatory. It is a stopgap. A brilliant stopgap, but a stopgap. Cassini's value, in retrospect, was not permanence. It was a single photograph of a moving subject, and we treated it like a portrait. And there is nothing currently funded, designed, or in flight that will replace it. Let me tell you what the mission gap actually looks like. Cassini ended in September 2017. The next dedicated mission to the Saturn system, Dragonfly, is scheduled to launch in 2028 and arrive at Titan in 2034. That sounds like the gap is bridged. It is not. Dragonfly is a rotorcraft. It is designed to fly through Titan's thick atmosphere and study Titan's surface chemistry. It is a brilliant mission. It is not a Saturn mission. It will not orbit Saturn. It will not measure Saturn's atmosphere. It will not study Saturn's rings. It is going to a moon, not to the planet, and the planet is what is changing. The actual gap from Cassini's destruction to the next dedicated Saturn system observer is at minimum 25 years, and more likely 30 or more. That is a generational gap. The scientists who will eventually receive new Saturn data are children today. The people who built Cassini, who flew Cassini, who analysed Cassini's data in real time, will be retired or dead before a replacement instrument returns measurements from Saturn orbit. This was a choice. The 2023 Planetary Science Decadal Survey, the document that sets US priorities for outer planet exploration through the 2030s, ranked a Uranus orbiter and probe as the highest priority flagship mission for the decade. The reasoning was sound. Uranus has never had a dedicated mission. Voyager 2 flew past in 1986, and that is the entire dataset. An ice giant orbiter would transform planetary science. But that decision means Saturn does not get a flagship in the 2030s. Saturn does not get a flagship in the early 2040s. Any Saturn return mission would have to compete in the next decadal survey, which means it would be proposed in the late 2020s, ranked in the early 2030s, funded in the mid-2030s, designed and built across a decade, and launched in the late 2040s. Cruise time to Saturn is 6 to 7 years, even on optimistic trajectories. The earliest plausible arrival is the mid-2050s. The decision to prioritize Uranus was not wrong, but it means Saturn, the planet currently undergoing observable transition, is scientifically orphaned. The rings are bleeding. The atmosphere is shifting. The auroras are deviating. And the only instruments watching are remote telescopes whose time is contested by hundreds of other priorities. The longer the gap stretches, the more the question shifts from what is Saturn doing right now to what did Saturn do while we were not looking. By the time the next mission arrives, the answer may be unrecoverable. Here is the part that requires care to say clearly. None of this is hidden. The JWST data is published. The ring rain measurements are peer-reviewed. The ring age estimates are in mainstream journals. The decadal survey is a public document. Anyone who wants to verify any of this can do so in an afternoon with a library card and patience. There is no conspiracy. There is no cover-up. There is something subtler and, in its own way, harder to fight. What there is framing, institutional framing. NASA's public communications around Cassini, almost a decade after the mission ended, still emphasized legacy. Legacy mission, legacy data, legacy science. Read the language. Legacy implies completed value, a contribution that stands on its own and continues to give. That is true in one sense, it is misleading in another. Because legacy framing carries an unstated assumption that the thing being honoured is finished and stable enough that honouring it makes sense. You do not call something a legacy if it is actively becoming obsolete. You call it a legacy when you want the public to feel good about what was spent and what was learned and what the institution accomplished. Funding cycles depend on that framing. The next flagship mission, whatever it is, will be sold partly on the success of Cassini. If the public understood that Cassini's data is starting to function as a historical record rather than a current reference, it would be harder to justify the next $3 billion mission as a continuation of that success. This is where the fairness clause matters. Space agencies are not lying. They are not deceiving anyone. They are operating inside a political and budgetary system that requires them to sell continuity. Admitting that flagship missions become obsolete faster than expected, that planets change on timescales shorter than mission cadences, that the data you collected at enormous cost has a half-life, would make every future flagship harder to fund. The structural incentives push toward triumph narratives. The structural incentives push against acknowledged gaps. The scientists doing the actual work know this. The papers being published in 2025 and 2026 are increasingly explicit about the limitations of Cassini-derived models. But scientific papers are not press releases. They are not documentaries. They do not reach the audience that funds the agencies. The framing the public sees, the framing that drives the next budget request, remains soft. The physics does not care about funding cycles. The physics does not care about legacy framing. The physics is telling us, in language that gets clearer every observation cycle, that Saturn moved on. Now widen the lens. If a planet we observed continuously for 13 years can become unrecognizable within a decade of mission end, what does that tell us about everything else we think we know about the outer solar system? The uncomfortable answer is that Saturn is probably not unique. Saturn is just the case where the gap between observation and reality became impossible to ignore first, because the rings are dramatic and the ring rain is measurable, and the JWST images are vivid. Look at Jupiter. The Juno mission, still operating, has been documenting atmospheric belt shifts that do not match the patterns Voyager and Galileo established. The belts widen, narrow, change colour, swap behaviours. The Great Red Spot is shrinking measurably year over year. Juno's data is teaching planetary scientists that Jupiter's atmospheric structure is not the stable banded pattern textbooks show. It is a dynamic system that happens to look similar across human timescales, while being structurally restless on longer ones. Look at Neptune. Voyager 2 flew past in 1989 and photographed a great dark spot, a storm comparable in scale to Jupiter's Great Red Spot. By the time Hubble looked again a few years later, that storm was gone. New dark spots have appeared since in different latitudes with different lifetimes. JWST's 2024 Neptune observations showed atmospheric features that nothing in the Voyager dataset predicted. Neptune in 2026 is a different planet, observationally, from Neptune in 1989. The intervening 37 years contained changes we did not watch, because we had no instrument capable of watching. The pattern repeats. Uranus, when Voyager 2 passed in 1986, was a featureless blue-green ball. Modern telescopes show seasonal storms, ring structure variations, magnetic field complexity that the 1986 dataset gave no hint of. The solar system, as observed across the limited windows of human spacecraft missions, has been treated as a slow-motion museum. The evidence increasingly suggests it operates on timescales shorter than human attention spans and far shorter than human funding cycles. This is the larger frame. Every confident statement in every textbook about the outer planets carries an unstated expiration date. No one has calculated those expiration dates because no one has the data to calculate them. We are working from snapshots that we treated as portraits, and the subjects of those portraits keep moving. Saturn just told us, in the most visible way possible, that our reference frame is too short, and we have no funded plan to extend it. The solar system is changing faster than our capacity to watch it. That is the real warning. Here is the verdict. Cassini was not a failure. The mission was extraordinary. 13 years in orbit, hundreds of thousands of images, discoveries about Enceladus and Titan that rewrote what we thought possible in the outer solar system. The grand finale alone, those 22 orbits threading between the rings and the cloud tops, produced data that planetary scientists will still be analysing in 2040. None of that is in question. None of that is being attacked here. The error was ours. We assumed 13 years was long enough to know a 4.5 billion-year-old object. We assumed the planet would wait for our follow-up mission. We assumed baseline meant baseline, and that the reference frame would hold until we got back. We assumed Saturn was a portrait, when it was always a freeze frame of something in motion. Consolidate what the evidence actually says. The rings are bleeding into the atmosphere at 10,000 kilograms per second, and the rate is not constant. The atmospheric chemistry has shifted beyond what seasonal models predict, on a timescale we have no model for. The rings themselves are between 100 and 400 million years old, a tiny fraction of Saturn's lifespan, and they will be gone in another 100 to 300 million years. We are alive during the brief window in which Saturn is recognizable. Before that window opened, there was no ringed planet. After it closes, there will not be one again. And the only dedicated mission to observe this window has been over for 9 years, with no replacement funded, designed, or in flight before the mid-2050s at the earliest. When you walk outside tonight, in the Dominican Republic or in California or in Tokyo or anywhere else this story finds you, and you look up at Saturn through a backyard telescope, or even just with the naked eye on a clear night, you are looking at a planet your textbooks no longer accurately describe. You are looking at rings your great-grandchildren may not be able to see at all. You are looking at the brief, bright moment in cosmic history when a planet wore jewelry, and the jewelry is falling off in real time. We did not finish studying Saturn. We paused. And the planet did not pause with us. The lesson generalizes. Every cosmic certainty has a half-life. Every reference frame is a snapshot. Every textbook is eventually a historical document. If you want to understand how often the universe makes that truth uncomfortable, the full case is laid out in a short book called The Universe is Trying to Kill You, linked below. Saturn is not trying to kill anyone. But Saturn just demonstrated, in the most visible way available, that the universe does not stand still for us. It does not wait. It does not pause when our missions end. It does not preserve itself for the next generation of instruments. It moves. And the only question is whether we are watching when it does. The rings are an hourglass, beautiful precisely because they are running out.